Good morning, Year 7s. Yeah, right on to our next lesson in the unit now, in our Shapes unit. I'm quite excited because I think it's a good one. This is going to be a lot of chance for extra challenge for those of you who like it this lesson as well. Before we get started, though, I have to say those flow diagrams that you guys made, where you were classifying the shapes and there was a different kind of branch for each individual shape. That was fantastic. That is honestly, I'm not like bigging you up or anything. That is the best I've ever seen that activity done. So just so you guys know, I saved a whole bunch of your guys' work onto my computer so I can show the year 7s next year. So fantastic work, lovelies. You have absolutely nailed that. Kind of as normal, you've done a fantastic job. So yeah, I love the flow diagrams. Hard activity and you nailed it. So good work, lovely 7s. Cool. Cool. Yeah. So our new unit then that we're going to do, our new lesson that we're going to do is on symmetry. Now, you guys will be really, really, really good at this already. That's how come I've got this kind of pitched as an extension lesson. So just to remind you though, from primary school, there's two types of symmetry. The first type that we're going to see is the one that you'll be familiar with called line symmetry. Now, symmetry just means that it's kind of both sides of something are the same. So when you have line symmetry, it's like this butterfly here in the top corner, that her one wing here on the left is equal to her other wing here on the right. So you might remember that from when you were in primary and you painted half a piece of paper as half of a butterfly, and then you folded it over and it matched up and it finished off the butterfly. So that's kind of the standard one that you do for art and for maths and stuff when you're in primary. So you might remember that from way back. So cool, that's what line symmetry is. Now, here we go. Oh, sometimes also called reflectional symmetry, but usually line symmetry. Now here we go. If I just show you these guys then, how many lines of symmetry does each shape have? Well, this triangle here, I bet you're shouting out already, so I am going to go a little bit quick for you on this. But yeah, how many lines of symmetry does it have? Well, one. It says, oh, that's not a very good pen. It's got one line of symmetry because it's straight down the middle like that. Sorry, I've drawn that really poorly, but it's straight down the middle like that. One line of symmetry just because you could fold it over and it would match up to itself. You couldn't do a line of symmetry this way because the triangle is an isosceles triangle, as you can see, not an equilateral. So we've only just got the one line of symmetry. Cool, cool, cool. Remember? Cool. The square then, lovelies. What are we going to get on our square? Well, I bet you can get that straight away as well. I bet you're shouting out already. How many lines of symmetry does it have? Well, and so there's what we've got, my lovelies. You can go up level, yeah, you can go horizontal, vertical, and either diagonals. So we've got one, two, get my clicker here. We've got 1, 2, 3, 4 lines of symmetry. So that's quite good. 4 lines of symmetry on the square, no problemo. And this guy here, this one's actually a little bit tricky. So just a regular old hexagon. How many lines of symmetry do you think that guy has? Have a little think. It's a bit tricky. I might have to actually draw this one accurately. How many lines of symmetry do you think that it's got? Well, lots of you, I bet you already, will be thinking, right, well, you can draw all these lines of symmetry. You can go, there's 1 there across diagonally, 2, that splits it in half as well, 3 across that way. So it's got 3 lines of symmetry, right? 3. Is that what you'd be thinking? But oh no, there's even more lines of symmetry on this one because you can go also having each side. So here's a 4th one, and a 5th one, and a 6th one. So the hexagon, actually, 6 lines of symmetry on that. So it's a little bit trickier sometimes to kind of know how many lines of symmetry, but that's it. So I hope that you remember the lines of symmetry stuff all the way back to primary school and that you're able to find them. Now, in lessons, I usually have people try all of these, so here's what I'll get you to do. Just push pause. You don't have to draw them. Please don't draw them. It'll take ages. Just push pause and, yeah, let me know how many lines of symmetry you think each one's going to have. When I take them up, I think I'm just going to say the answer, so in case I get any wrong, it's perfectly okay to kind of correct me when you get down to it. Cool beans? When you submit your homework, say, actually, Mr. Wade, you got that one wrong. That's cool if you want to do that too. So you ready? Go! And you're back, lovelies. Okay, if I was to have a little guess through all of these guys, I would say that this has 1 line of symmetry across like that. I'll bet you this guy here, 1 there and 1 there. So 2 lines of symmetry. I would think that this doesn't have any lines of symmetry at all. because if you split it up and down, well, it wouldn't match up. If you split it on a diagonal, it wouldn't match up. If you split it horizontally, it also wouldn't match up. So I think that's 0, but again, correct me if I'm wrong. This guy here, now, this is a funny one. I think if you ignore the colors, that it's got loads of lines of symmetry, but if you count the colors, it's got no lines of symmetry at all. And here's why. If I was to put a line down here where there should be a line of symmetry, I would actually have this blue matching with this white. So I think that this one has no lines of symmetry because of that. Because no matter where you put it, where the lines of symmetry would normally naturally go, like that and like that and like that, well, I suppose you could say that there's, how many would it be then? Would there be 1, 2, 3, 4 lines of symmetry? There should be, but if you look at the colors, I reckon it's 0. So, funny, funny, funny. Cool. Next one here, E. I would think that it's got 1 there, 2 there, and I would think that the diagonals wouldn't match up. I wonder if they would match up. I don't know, actually. Will that match up? So it would start by going out and around. Actually, I think that would match up. So I think we've got 1, 2, 3, 4 lines of symmetry again. And for F, what we've got here is definitely that one. 1. The yellow triangle, if you cut it in half as well, maybe. Oh, it's trickier than I thought. Oh dear, my lovelies. I thought this would be nice and easy, but I think I'm finding it tricky. 2. Where's the other one? Oh, 3. There it is. Cool. I reckon that one's got 3. If you went across this way, it wouldn't match because the red point would be down, I think. But anyway, let me know what you think. Make sure you pop me a correction if you think that I've got it not quite right. Now, here's the more interesting things. I think this is cool. So right here we've got our flag, the UK flag, the Union Jack flag. And how many lines of symmetry do you think it has? Well, I'll give you something neat. I don't know if you guys know this or not, but if you split it, you'd think like that for sure and that for sure, right? So you'd think like 2, not the diagonal one, because in the diagonal one, it's going to be a rectangle, so it won't match up quite right. So this point would end up here rather than on top of that. So you think 2, right? I don't actually know if you guys realize this or not, but did you know your flag doesn't have any line symmetry at all? Oh no, it's all weird actually. So the Union Jack, even though it looks like this beautiful, symmetric, gorgeous, like cool flag that everyone in the world knows about, it's actually not got any line symmetry at all. Here's why. If you check out this part, can you see the white bar? This is way wider on the top here than it is here. See, it's thin there and it's wide there. So the wide bits actually don't match up because on this left-hand side, the wide bit is on the top, and on the right-hand side, the wide bit's on the bottom. So actually, because of that, and the same top to bottom as well, it doesn't match up. This is on the bottom, and then it's thin on the top, but wide on the bottom. So no matter how you look at it, I'm afraid the beautiful Union Jack flag, our flag, the UK flag, is not got any line symmetry at all. Whereas my Canadian flag actually has 1 line of symmetry, even though it doesn't look like it has symmetry. We're straight up and down like that. And the Canada flag actually does fold in half, whereas the UK flag does not. Cool. Happy days? Sweet. Okay. Next little bit, guys. Rotational symmetry. Now, this is kind of neat. I'm going to go through this quick, but there's something called the order of rotational symmetry, okay? Rotation symmetry is this. If you twist a shape around, how many times does it click onto itself? So you see this red diamond shape here? It's a red square, it's a red rhombus. What you're going to find, it's a red square actually, is that as you twist it, it's not matching, not matching, not matching, boom, matched once. So that's 1. Not matching, 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 not matching, not matching, and match. 2. 3 clicks on, and 4. So basically, well not basically, exactly, this has got an order of rotational symmetry of 4. That means it matches onto itself 4 times. The smallest number you can have is 1. And the reason why the smallest number you can have is 1 is as you twist the shape around, it'll click onto itself once at least, because that means it's gone all the way around. How about this guy here? How many times does it click onto itself? If you said 4, you're exactly right. Check it out. Once clicked onto itself, twice, 3, and 4. So that's got 4 as well. How about this one and this one? What do you think? What do you think, lovelies? Well, if you got this one, the arrow, as 1, you're exactly right. Because look, all the way around, not matching, not matching, not matching, bang, back into position. So that guy there, 1. And this guy here, the hexagon, it's got 6 sides. What do you think? Well, let's see. 1, 2, 3, 4, 5, 6. So it is exactly like you thought, lovelies. 6. So this has got 1 and that's got 6. And that's what rotational symmetry is, okay? Now, here you go. Final thing. These guys. Write down what you think the order of... Write down what you think the order of rotational symmetry is for all 6 of these guys, plus your cool Union Jack flag. So you ready? Go! Okay, and here's what I think. In this first one here, I reckon the answer is 0. Because it would click in upside down, but then the black would be where the white is, and the white would be where the black is. Oh, sorry, so that's 1. Sorry, not 0. 1. Because it would match with itself once in the original position. This would be twice, because it would be the same upside down. This would be 3 times, because each point could switch position. This would be 1, 2, 3, 4, 5, 6, 7, 8 times. Because the thing in the middle is a circle, so you don't have to worry about it. It clicks on an unlimited number of times, and there's 8 points. This guy here, I think, would just be 1 again, because it would only just, when it's pointing upright, it would be at the spade or whatever that is from cards. And this guy here, I think it would be 1 as well, because... would it be in the opposite orientation when it's upside down? I think that this bar would be pointed that way when it's upside down, so I bet you it's 1 as well. Now, here you go. Oops. Union Jack. Here you go, my lovelies. There's something neat about it. So even though you didn't have any line symmetry, my lovelies, what you do have is you do have it matching up once, the Union Jack. Up, so all the way around, and boom! Look, guys, it's the same upside down as it is right side up. So there it is, back right side up again, and upside down. It's a perfect match both ways, which means that the order of rotational symmetry for the flag is gonna be 2. So nice one, lovelies. And that is it. Now that's it for content for this lesson. But remember how I said I was gonna give you a super challenge? Okay, I like this activity. It's really hard. I've never taught it online before, obviously, so it usually takes a lot of explaining as well. So let me do my best. Okay, I've got a really cool flag challenge for you, and there's a mathematical secret buried in it. Now, I'm only going to make you do half of this activity, but those of you who really love maths and want to do extra, because I do think it will take longer than the 45 minutes to do the whole thing, I'm going to give it just as an option to finish it. You don't have to if you don't want to, but you have to do some of it. Here's how this works, lovelies. I'm going to get you guys to be inventing flags. Now, for a flag to be a cool flag, well, these are cool flags too, up and down here on the right-hand side. But to get a really kind of cool looking flag, I want 2 things to happen. The flag has to have at least 1 line of symmetry. And if one flag is a rotation of another, it doesn't count. Okay, so these are the 2 rules I want. Now, we're going to be making our flags on 3x3 grids, which I'm going to give to you here. Okay, so I'm going to attach this, and you can print that out, and you've got so many 3x3 grids that you've got tons of chance to experiment and see what you can come up with, okay? So you're going to get that attached, so that's what we're going to do. But here's what I mean. Since it's a square, there's only a few lines of symmetry you need to worry about. So the flag has to be symmetric this way, so that would be up and down, so vertical line. They can be symmetric this way, horizontal line, but specifically because it's a square, you do have the 2 diagonals to consider as well, okay? So there we go. Those are your potential lines of symmetry that the flags match with. So if you look at this very first flag here with the pink square in the corner, is it a good, valid flag? Well, yeah, it is, because it does have at least 1 line of symmetry. And here's that line of symmetry. It's the diagonal, so it does fold over, it does match up. So that is perfect. Now, what you're going to get then on this guy, on the green flag here, is it a valid one? Well, yes, it is as well. Where's its line of symmetry? Well, it's the long diagonal again. It's that main diagonal again, because it would fold over and match. So you can see both this and this are a valid flag. Cool, cool, cool? Good. So that's rule 1. They all have to have a line of symmetry. Now, rule 2 is if a flag's a rotation of each other, it doesn't count. So if you check it out, this blue one here, it does have a line of symmetry, so it's a valid flag because vertically up and down is the line of symmetry. But you can't have this one and that one because this one here on the right is just a twist of this one here on the left. See, I'll show you. Look. See, it's the same flag, so you don't get to count it twice. You can only count this one once because whether it was up and down like this, that's the flag we started with, and so when you twist it over, it's the same flag, it's just twisted. So this is only counts for one. So both of these flags are only just one flag. It's the same way as, look at, there's my Canada flag, but it's upside down. That doesn't stop it being the Canada flag, it just makes it upside down. So I can't count this twice, it's the same flag, one's just upside down. Get it, guys? Okay, good. Here's what we're going to do. It's quite tricky, this, but here's what we're going to do. Just on the blank grids, here's what we're going to do. We're going to start by figuring out how many flags there are that have no squares filled in, 1 square filled in, 2 squares filled in, 3 squares filled in. Now, this is going to be where the homework ends, though, okay? So you all have to do 0, 1, 2, or 3, and tell me how many possible flags there are. Now, those of you who want an extension, try 4, 5, 6, 7, 8, 9. Okay, so that's extension. You do not need to do this, okay? So if you are keen about maths and you want to try it, it's really neat. Now, I'll tell you why it's neat, just to try to entice you to do them all. But again, I'm really not pressuring you. 0, 1, 2, and 3 is fine. Now, here's what you're going to do then, guys. The 4 is neat, okay? So if you're going to be one of the extendy ones, 4 and 5 are neat. When you do 4 and 5, you're going to notice something, which will give you a hint for 6, which at that time, you'll spot a pattern, okay? Now, you'll have discovered something really fascinating in maths if you do those, okay? So 0, 1, 2, and 3, everyone has to do. If you do 4 and 5, something interesting happens, so look at that. Something interesting happens there. And then 6, 7, 8, 9, you'll already have the pattern, so it's easy peasy. Cool. So here we go. I'm going to do 0 and 1 for you. So you'll only have to do 2 and 3 then, guys. So it's not actually a big homework. So 0 and 1. How many flags are there with no squares filled in? So there's our grid to draw it on. How many flags are there without anything to fill in? So I'll get my highlighter here and, oh no, wait, I can't fill it in because you're not allowed to fill in any squares. So how many flags are possible? Well, it's not none, it's 1. You can have this plain white flag. So with 0 filled in, there is going to be, so filled in, and then how many flags are possible? Flags possible. Well, with 0 filled in, there's 1 flag possible. It's this one. How many flags are possible with 1 filled in? Now, this is where you're going to have to pay attention because you'll have to do 2 and 3. Now here you go, with 1 filled in. Well, let's start off. Remember, we've got to have 1 line of symmetry, at least 1 line of symmetry, and rotations don't count. So here we go. To start off with, let's grab the blue highlighter. Oh dear. Oh, I can't write on it. Oh dear, disaster again. Disaster has struck again. Oh no, green highlighter. Oh no, disaster's really struck again. Oh well, colored in this way. So with 1 filled in, draw with touch. Oh dear, sorry lovelies. I don't know what's going on. What's going on? Have I fixed it? Can I write anywhere? Oh no! Oh dear, disaster, disaster. Can I write with my mouse? Oh dear, oh dear, oh dear. We're there. Okay, sweet. Okay, let's see if I can switch to the pen. Please, 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 please. Oh yeah, and we're back on the pen. Anyway, sorry about that. Here we go. So with 1 filled in, that's perfect. That's certainly one way because it's got that line of symmetry that's here on the diagonal. So that's cool. That's the one way. Cool. Next way, well, we could have it here as well. If we colored in this one as a second flag, that would be cool too. We could have that one too, because that's going to be a line of symmetry down the middle. Now, how about this? If I put one here and colored that in, is that a different flag as well? What do you think? If you put, well, colored in there, does that count as a different flag? Well, if you said, no, actually it doesn't, you're right, because here is Y. If you grab this guy and twist him 90 degrees, if my grid was perfect, that would actually be the same flag as that one. So you can't count that one because it's a twist. It's the first flag twisted 90 degrees, so that's not a new flag. So we've only got 2 flags so far. So where else could we color in? So we can't color in the top right square. That's not allowed. Could we color in this left square? Well, no, because the left square, if you colored in here... Oh, I've lost the pen again. If you colored in there, that wouldn't count either because that's this second one twisted over to the left. So it doesn't count either. So, oh dear. So how about the middle square? Can we color in the middle square? Well, yeah, we could color in the middle one because that's new and it's got several lots of line symmetry actually. So you could go vertically, horizontally, or either diagonal. So that's perfect. That counts as well. And what about this next one? What if you go to the right? Well, no, because it'll be the same as this one. What if you go here on the left? Well, no, because it's a twist of that one. Down here? Well, no, because it's a twist of that one. Down here? No, because it's a twist of that one. So how many flags exist with one colored in? Only 3. There's only 3 flags that pull that off. Do you get how we're doing it, guys? Cool, cool, cool? Okay, so your job then is to use the same logic that I've used for 2 and 3. So I'll give you the very, very first one for the 2's, okay? So here you go for the okay, if you're going to color in 2, so 2 colored in. Well, if you wanted to try that, here's one possibility. You could have this corner, and you could have, well, not this corner, because not that middle, but maybe this corner. That would be an option for the 2 colored in, because the line of symmetry for that would be down the middle, and it would match up, okay? See what I mean? There's one of the 2 colored in ones. Here's what I would suggest that you do though. You need to go through quite systematically, which means I need you to go through slow and careful. Otherwise you might not get them all. So try to come up with a pattern. So I've left this top left one colored in. Maybe I'll see what happens as I move the other blue square around, for instance. Get it? Cool. So your task is, one more time, to finish this off for having 2 squares colored in and for 3 squares colored in. Now, if you proper love maths and you want to keep going, you don't have too much on today, try it for 4, which is going to be hard. Try it for 5, which is going to be less hard. And then just be like, oh yeah, and you'll get it for 6, 7, 8, and 9 instantly because there's a secret pattern happening. Cool beans, guys. Right, so that is it for today. That's it. Really good work one more time on your stuff last time. And good luck filling this in. I'm going to attach this sheet so that you can fill them all in on that. So you can do the 0, which I've already done, 0 colored in. So that could just be this one. And then you could go for the 1 colored in, draw them all on here. Those 3, do the 2 colored in like along there. And then the 3 colored in along there. And if you wanted to keep going, all of these flags are for all the way up to 9. You won't need them all though, so don't worry. There's lots of room to make mistakes if you make a mistake. And that's it from me. So really fantastic work again, lovelies. And I shall see you next time. Bye, lovelies.